Hello, everyone. My name is Mr. Baxter. I am going to be your sixth grade summer enrichment math teacher. This week, we're going to be talking about unit rates and unit prices. They can seem very similar, but there are some differences. Hopefully, you all were able to yesterday look at the things that I wanted you to view. One of those things was our week one vocabulary list. So if you look to the right of the screen, you see the second thing says review week one vocabulary list. I'm going to open that. And whenever you have something for me, make sure that you always go ahead and present the screen so that you can see it in its entirety. So we had three words this week. The first word was rate. We're not going to concentrate on that right now, but we will concentrate on the next two. All right. The first one was unit rate. Unit rate considers how much of something per one unit of something else. So we have an example here because I don't know for you, but for me, sometimes when I read math definitions, it's a little harder for me to understand as opposed to when I see an example. So here our example says that 200 burgers were eaten by 50 people. All right, that may be a fine fact. However, we want to know how much one was. So here, if we were to divide that, we have four burgers being eaten by one person. So a unit rate, once again, always goes back to see how much one will be. The next thing that we have is a unit price. And a lot of times students get these confused because you kind of solve them the same way. However, unit price refers to things that have money in it. All right, we're trying to figure out how much money one will cost. In fact, the definition says the cost per item or unit. So for an example, we have 2 liters of pop or something else. Let's call it pop. 2 liters of pop being sold for $6. That's great. We want to know how much 1 liter of pop will cost. Now, whenever you have unit price or you're dealing with money, you always want to put the money on top. You'll hear me say it several times in the different slides that I give for you throughout the week. There will be reminders that say, remember, always put the money on top. What do I mean when I say that? Well, if we write it as a fraction, the number always needs to go on the top in the numerator. All right, so here, even though the 2 came first, we're going to put the money in the numerator on top, $6. All right, and what are we going to divide by? 2, because we know it was $6 for 2 liters. If we did 6 divided by 2, what will we get? Well, we'll get $3 per liter, right? I don't want to just leave you with that. We're going to do some examples. This is one of the examples that you see for today, all right? So we're going to consider unit rates in story problems. And basically the things that you'll need today is a pencil, paper, and a calculator, all right? If you don't have a calculator, I have provided an online calculator for you. So if you click that, you will be able to go to an online calculator. If you want to, you can watch the video first. It'll probably be about 10 minutes, and then you can watch it again and follow along with pencil and paper if you need to. That's totally up to you. All right, so let's go ahead and go over this first example. It says a piece of space junk travels 14 miles in 7 seconds. And here's the question. How far does it travel per second? So to do this, we need to get some pertinent information. Right? Find all the important information. The first thing I ask students, what is it talking about? And the first thing they like to tell me is it's talking about space junk. Yes, while that's true, that doesn't really give us any numerical values. All right. If we continue to read, it does when it tells us that space junk travels 14 miles. All right. Next, and I'm going to use a different color because we're not talking about miles anymore. All right. It tells us that it does that in 7 seconds. All right, so I need to set this problem up. And when I set it up, I'm going to set it up in a fraction. All right. Now, if we look at the question, it says, how far does it travel per second? So we want to know how many miles the space junk travels per second. Okay. Now, some students just want to guess where the numbers are. Sometimes they'll put the 14 in a numerator, or in other times they put it in a denominator. All right, you have to think about it. We can't put 14 here. Think about why. Why wouldn't you be able to put the 14 there? Well, yes, because if you put the 14 there, it's going to say 14 seconds. That's not what our question said to us. Our question said 14 miles, so we're going to put it in the numerator. Next, 7. This is the only place 7 can go, and we can check it to make sure that it goes there. Well, we are referring to 7 seconds here, and that's what we have right here. Next, I'm going to just clean it up a little. 14 over 7, right, or 14 sevenths, is a fraction which can be expressed like this. 14 divided by 7, right? You should know what 14 divided by 7 is, but if you don't, no need to worry. You have your calculator ready for you. You can go ahead and compute that and get 14 divided by 7 is 2. Now, you cannot just leave it like this, right? While 2 is our answer, I need a little context. I need to know, what are you saying when you say 2? Well, the question says, how far does it travel per second? All right, and we're going to look here to help us to write it out. It travels 2 miles per second. This is the answer to our question. All right. Now, I don't want to just leave you with one example, so we're going to do a couple more. Here we have a problem. It says a skydiver falls 144 feet in 3 seconds. How far does the skydiver fall per second? Once again, you go ahead and underline the pertinent information. 144 feet. All right. And I have some students that will say, like, it doesn't have another number. It does have another number. All right. If you look, it says 3 seconds. All right. So now we need to go ahead and write that out. What are the two things that we're talking about? Well, we're talking about feet and seconds. Just in case you are wondering, like, what can I put seconds in the numerator? If I could put seconds on the top? Well, we got to look at that question. It says, how far does the skydiver fall per, remember this says per second. All right. So feet per second is how it needs to be written. You put the numbers where they go. 144 has to go in the numerator because it's talking about feet. 3 has to go in the denominator because it's talking about seconds. So if we clean this up, we have 144 divided by 3. Well, now you have your calculator. You can go ahead and solve that and write down what you get. If you do 144 divided by 3, you will get 48. Now remember, we need to go back and look at our units here. Feet per second. That is our answer. So the question, how far does the skydiver fall per second? Skydiver falls 48 feet per second. All right. And let's do one more. This one is a little different. If you remember our vocabulary, all of these we're considering rates. We were looking at miles to seconds, feet to seconds. Now we're looking at pounds to money. This isn't a unit rate problem. This is a unit price problem because we're talking about money. So now when we read this, it says Charlie purchased 18 pounds of dog food for $4.50. How much does Charlie pay per pound of dog food? Now, I'm going to do this problem wrong. I'm going to show you how some students do it. So don't write this down. In fact, I'm going to do it all in red. All right. Some students will go and they'll say 18 pounds and they'll say $4.50. All right. And then they'll just write it out like this. They saw pounds first, so they wrote pounds first. And then next they saw the money, so they'll write the money. And they get 18 divided by $4.50. Now let's look at this and see how we should have solved it. All right. So I want to leave that there in red so we can see that it's wrong. And let's look at how we should have solved it. All right. Yes, it is talking about 18 pounds of dog food. Yes, it is talking about $4.50. But remember that rule that we said we always want to follow. Money always has to go on top. All right. So when we set our problem up, our money or our costs should go on the top. And then what we're referring to, pounds, will go in the denominator. Now we see that the $4.50 has to go in the numerator, and the 18 has to go in the denominator. Why? Because the $4.50 was talking about the money, and the 18 was talking about the pounds. Money always goes on top. Now, we probably don't know this right off the top of our head. Even if you think you do, just go ahead and check it in your calculator. Make sure that you don't just type in 450, because that's not the number. 4.50 divided by 18, because this is what we have. When you do that, you'll see that you get the answer 0.25. Now, since we are talking about money, right, we need to have our money sign. And that essentially means that we have 25 cents. Now we have to finish our answer. And to do that, we need to look at our units. Now I don't have to write 25-cent money, right? Because it's already in written that way, 25 cents per pound. So how much does Charlie pay per pound of dog food? Charlie pays 25 cents per pound. All right, so that's the last example I want to leave you with. If you have any more questions, though, please feel free to reach out to me, patrick.baxter@leonagroup.com. You can send me an email, or you can text me in a number that's provided on the slides. All right, you all have a good day, and I will see you next time.